Welcome to the Testing Habits podcast. This is Eduard and Robert, and today I'll be speaking with a man whose work I greatly admire, Robert Feldt, a professor of software engineering at Chalmers University of Technology in Gothenburg. So he thinks broadly and deeply about software testing, requirements engineering, and human aspects of software development. So we had a good, energetic conversation, which I greatly enjoyed, and I hope you will too. So I give you Robert Feldt. My guest in this episode is Robert Feldt. Thank you for coming to this show. I appreciate it. So for the people that don't know who not familiar with your work,
right.
I would like to know more about you and how do you got into software engineering and research?
Right. Thanks for having me. So I guess I got into computers really early on. So I really started as a hacker in a sense. So I got even before the Commodore 64, I had a Texas Instrument.
Wow. Yeah.
And I was learning BASIC on that. I think I might have been 7 around that time.
Oh, right.
And
BASIC was the first language.
Yeah, I think it was BASIC. It was right about that time. And my father was really supportive. I don't think maybe that was the key thing, but at least it helped. So I remember early on that we got there wasn't that many Swedish journals or magazines about this. So we got like a German magazine where there was a code listing, but it was actually assembler or something. I mean, basically the bytecodes or something. And my father and me kind of took turns. For hours writing that in there. And I don't remember what it was about, and it wasn't really important what the program did, but it was kind of like, I really got an early sense that it was a fascinating machine and stuff like that. And I continued early on to do demo programs for the Amiga, was my main thing when I was older. And actually I sold a program very early on, so it was pretty clear to me that I wanted to go straight into computer science or more practical, I guess, because I've been kind of programming since very long.
Yeah, I had the same experience with my dad and everything. I just went like this. It's like you discover computers, you know how they work. This is like the first thing. It's a wow factor, basically.
Yeah. And the whole idea that you could kind of, I don't know, that you could tell this thing to do something, and I was never very good at physics or like the practical stuff even. I was good at mathematics and I liked programming. And I think the thing really for me was that it was really creative. I could go from an idea to see it in like an hour. I did demo programming, so it was really kind of hands-on. And this is what, so I think for me, programming in computers has always been not what you see in the normal culture. Normal culture, it's like something boring, that they just follow instructions and so on. For me, it's like they are like tools for being creative very quickly, and you can kind of turn mathematics and ideas into something that can affect people. So I think this was really why I was interested in computers, and so it was really natural to go to Chalmers. I was from Gothenburg. It was all the time natural. I would study computer science and engineering at Chalmers. And then the first summer, my first year at Chalmers, I got a job as kind of a software developer and tester in a small company doing the signs on buses here in Gothenburg and other places. And so I started consulting for them. So all through my education I did this. So coming to the end of my education, my master, I felt that I kind of know what the industry is, and I'm not so impressed. It was like classic stuff that the business or salesperson, they sold something we didn't have.
Yeah.
And the manager, the owners were happy. And then they told us that you have 2 weeks to show a demo, and then you worked like all through the night for 2 weeks, basically, right? So that was my experience, and it was not like I didn't like it. It was just that it felt like it's not really an optimal way of working. It's kind of stressful. So I got the opportunity, got the scholarship at Chalmers to do a PhD, And the scholarship was quite important because I could select the topics. It was not like I applied to a project. I could select the supervisor and the topic.
Oh, that's great.
So it was a really special thing, and I wanted to make then computers more creative and more soft in a sense, and the programming of them more soft. So I tried to apply biological algorithms to create software and create test cases, and that was late 90s, and then a few years later there was a famous paper called search-based, basically, with that coined the term search-based software engineering. And then I realized I had been doing that. So that was a kind of a nice, and then it just went from there. It's kind of, so it was really about how can we take this computers and software as a creative force and make society better. And you know, it might sound idealistic, but that's been it for me then.
These are all like towards the end. You mentioned some important topics like search-based software engineering.
Right.
And these are important. I'm thinking we can go through them. But
Yes.
What are you currently focusing in terms of research?
I would say I'm kind of partly the last few years I've been coming back to stuff that I was focusing on in my PhD and when I started out in research. I would say in the middle, after my PhD and up towards becoming a full professor, I think I kind of branched out and did a little bit of everything. I was more opportunistic. I kind of did what I could get funding for. Not really, you know. I always kind of did also what I wanted, but I was less picky and so on. And it was good, you know. I got to see many different stuff. But I think now I'm back to kind of core things like what is software quality, how can we create test cases that ensure a certain quality, what does it mean to, I mean, are there limits even to what you can do with test cases? And then I have maybe in some sense what I see is more valued currently is probably the more psychological and sociology, you know, applying ideas and models and results from psychology and sociology to software engineering situations and problems. I think these are maybe my two main strands, but I try to stay pretty broad actually. And you can also see that they are quite different.
Yeah, they're very
One is more hardcore, it's like information theory, automated testing, interactive approaches for solving software engineering problems are really important. But the more behavioral software engineering is something we try to get some interest in and to really take psychology seriously in understanding how it affects developers.
This is very, very interesting. But is it an easy way to explain to someone that doesn't do research what's, let's say, for example, search-based software engineering?
Yeah, I think search-based software engineering, I don't know if there's an easy way, but in some sense it's like instead of putting a lot of human hours and effort and, you know, sitting down for long, having meetings, deciding what the software should do, maybe you still have to do that, but how it should do it and how it should be structured and expressing that. Instead of doing all of this manual work, we try to take the currently quite powerful computers we have and let them help us with some of these problems. So we tell them what our goal is, and then we let them use, you know, days, months, years of computational time to approach those goals. And then we can maybe select and we can say, is it good enough? Is this test case helping me? Is this design better than the one I had yesterday? These type of problems, we can apply now our own tools, our own software, our own computers to help us in this quest. And I'm not saying we will not supplant humans, but we will support them and we will give them alternatives, look at the consequences of different design choices or different implementation choices.
But you started with studying artificial intelligence, machine learning, and then you got normally to...
Then I got into trying to applying these things into software engineering problems. And,
would you say that this is like one of the most successful areas of research in testing, in software testing? Or
no. I wouldn't. No, I think I think it's not even at the level where I can point to a tool that industry can download and use. I think the approach of using AI, machine learning, and search optimization is really powerful.
Yeah.
It's very popular, and it's very powerful, and you can really solve problems with it.
Yeah.
But it's not like a box I can give to someone and they can do it. It's much more complex than that. It shouldn't be, but it's still. So is it successful? I mean, in terms of publications, and you see many, the largest conferences in software engineering have a lot of tracks for this, and there's a lot of papers. In that sense, it's successful. In terms of industrial impact, it's not yet successful. But then again, not many things are, in a sense.
Yeah.
I mean, there's a lot of gaps.
Yeah, that's true. And I don't think there are too many things that you can pinpoint in research that went into industrial adoption quite quick.
But unfortunately, I think a lot of the search-based software engineering research makes assumptions that are not always realistic, and thus the solutions are not as good as they could be. I think it's time, we know now, 10, 15 years later, that we can do a lot with search optimization, even now machine learning and simple AI approaches. But we are not, in my opinion, in many times, we are not very good at applying them in a realistic sense. So we don't really know how good they are or how good they could be. And I think they could be really good, but we need to go out there and really do that work.
Yeah, but it's interesting for me to see this combination that you were one of the pioneers of search-based software engineering.
Yeah, in a way.
Or that's
yeah, I don't know.
and in the same time, you're very passionate about psychology and social aspects of software engineering. So how did you come to study sociology, psychology and human aspects?
Right. Human aspect, yeah. So I think it was my probably, I don't know if it comes earlier, but at least when I was starting out as a consultant, because before that I more sold the software, so I didn't really see the company.
Yeah.
It was more like simple requirements, and then you do it and then you sell it. But when I started working as a consultant at this small bus sign company, I could see that, I mean, it's not like a technical solution would solve their problems. I mean, in some sense, better technology can improve what many industries and companies do. This is obvious, right?
Yeah.
But does it solve all the problems? I think it's very rare that it can. I mean, often there's much more complexity in understanding the environment, the people, the teams, the politics. All of these aspects in any company and also in software companies are probably as important. And I think from my perspective, this has always been obvious. And I find the opposite viewpoint that only focusing on the technology would be the natural and would solve all problems. I think that seems unlikely to me. I think it's a technological, it's typical to do this. You can see in the culture, you see many examples of this, like Frankenstein. I mean, there are many cultural elements that try to touch on this problem, that we think that a purely technical solution will solve our problems. I think it's unlikely. So very early on, I took sabbatical during my master studies, Chalmers, and I studied for 1 year psychology at the Gothenburg University. So I had this sense that this is going to be important. I need to understand a bit more of it. Then it took a long time for me to actually do studies and research on this, and even longer to get it published. I think that, of course, over the 30, 40 years, there's been many people pointing this out. It's kind of obvious in retrospect, but it's not been very easy to do empirical and deeper research on this and get it published. So I think this has happened maybe the last 5 years.
Yeah.
That it's become more fashionable. And now it's very clear. I think our BSc paper that tries to define and clarify the terms and see what's out there, I think in a year or two since publication, it has maybe 50 citations or something like that. I mean, it's very clear that this is something is happening around this right now, right?
But it is I'm curious. Do you actually think about spending time on doing research only in this, or or you usually like combine different areas?
Yeah, I don't have like explicit and clear strategies and plans. It's more that I kind of think deeply that some approaches are more likely to be part of the future way we solve some of these problems, and I try to work in those directions. And then it depends on, can I find a company partner? I've been very lucky now to have a Swedish aerospace company that came to us and wanted to investigate these approaches, and these models and ways of thinking. Without that, would I push and do research in this area anyway? I'm not sure. Slowly, but slower. So that's why I think I keep all of these things going. I tend to select problems based on what I believe in and what I feel passionate about and feel is fun. And then hopefully the projects and the money and funding to do that can come after that.
Yeah, and it usually happens.
Yeah, I think so. At least
hand.
for me, so far it's been okay.
Yeah. Now, I would like to talk a bit about empirical studies and evidence, because it seems like this goes throughout your career, yeah?
Yes.
In a way, even if you did a lot of, I guess, technological advancements and papers about that, you have one core thing, it's the empirical studies and evidence. And why should it be important for software companies or software engineers to have empirical evidence and look towards that? Is this important for companies, or this is more important for science, or for the science of software engineering?
Well, no, I think my experience is that it's maybe even more important for companies. I think, isn't this the classic way they criticize academia, that we sit on our own and we do theories, and when we do any empirical study, it's like a toy example that has no scalability, no problems of scale and so on. So I think companies are probably more focused on what is your evidence for this, and you can have nice theories. They can probably be quite solid, and they can be consistent and whatever, but they are still kind of unproven theories in a sense, and that's probably not enough for a company to invest heavily in that, right? So I think it's crucial both for companies and for science, and I find the opposite viewpoint kind of strange. I'm not saying that. Clearly mathematics and theoretical computer science are really, really important, but should they then be the way we do computer science or applied computer science and software engineering? I doubt it, and I don't think that companies would prefer that.
Yeah, I am of the same opinion, but
Yeah, but of course people can have different opinions, but I happily would like, or I even tolerate and respect many of my colleagues who do theoretical research, but I must say many of them have not shown the same respect for people that are more applied and working more empirically. So, I think for me this has been maybe also a driver to be maybe more empirical and show that there's value, or try to show that there's value in that approach. Because for sure I have felt throughout my academic career that it's much more respectable and nice and intellectual to do theoretical and formal research in these areas. And I don't agree.
Okay.
I think both have value, and both should coexist,
Yeah.
and both should probably strengthen the other, rather than pretend that the other one shouldn't exist.
So do you think right now is that, because I think a lot of the conferences, and maybe you can tell me if this is not true, but ICSE and a lot of conferences now, they have a lot of empirical research, or not a lot, but some.
Right.
Is this empirical research or empirical studies are driving also the theoretical advancements?
I don't think so. I think it's not yet at the level where you can have a clear communication between these two groups. I don't think so. If you just look at the conferences, I think I agree with you that ICSE, ISTA, maybe other conferences, let's say that if you go 15, 20 years back, maybe they were at least they had more theoretical papers, and even all the papers had maybe less focus on the empirical validation or evaluation. So I think, actually I have statistics on this, but I mean it's not out in a paper yet.
Yeah.
But I think there's a clear trend that both conferences that have empirical studies as their core and journals have gained more citations in a sense. I mean, I have some statistics on this. And that overall this has affected all conferences. So you see more focus on not only empirical studies, but also more mature ways of evaluating and designing for empirical studies.
Yeah, that's interesting. But let's talk about software testing, because we talked about software engineering, and I think one of your areas of research is software testing.
Right.
Right. And as a scientist, which do you think are the most useful research ideas and techniques that one should try to know about or to learn as a software engineer or as a software tester?
So you mean like existing ideas from research
yes.
that you should learn about?
Yeah.
I mean, I'm not sure about this one, but I think there's also some evidence that the transfer is happening now on this, but I think mutation testing is pretty powerful. Yeah. I know that many researchers know this, have used it for their studies, and they've also had lots of critique for it, but because if we only evaluate our tools and advancements with mutation testing, I think that there's a clear risk, and there are papers showing that mutation, so basically mutation testing is that you insert and inject a fault, and then you see if your test suite finds it. And the number of times, if it often doesn't find these bugs, then it's probably a worse test suite than another test suite where you find more of these bugs. But there has been papers showing that real bugs are not the same as these fake bugs in a sense, right, that you introduce. So I think there are some questions about it. But I think the technique itself is genuinely a powerful idea. And you can see it now when there are well-supported Java available tools, open source, you can download, you can run it, they are fast, they give you something. Then many practitioners know about PIT, the PIT test, and other tools. But in particular, I think PIT has increased the use in industry and open source projects of mutation testing many times.
But so
that's one.
One. Let's talk a bit about mutation testing. So do you think how do you think this could be used in industry? Is it something that you have inside an IDE, or something that you use as a developer when you're trying to create tests or evaluate your existing tests, or mutation testing is a way of thinking about your tests?
No, I would probably say it's pretty concrete. I think you can download PIT today.
Yeah.
If you're a Java developer, you can download PIT, and I think you can get a lot of benefit from that. So I think that the foremost one is that you kind of get at least a relative sense of if you're improving your test suite. So if you're writing new tests tomorrow, and you run PIT today and then after tomorrow, then you get some kind of sense. The tests I added, are they helping me find some problems that at least theoretically could happen? And there is some evidence that at least some of these fake bugs have similarity with real bugs.
Yeah, there are a couple of compelling studies on this.
So for sure it's not the same thing as real bugs, but I mean the same idea we can apply even if we have real bugs. If we had good databases with real bugs, we could use mutation testing tools to inject those bugs or similar bugs and so on. So, no, I think I don't think it's so much. The industry doesn't need to think about mutation testing. I think they can use it. Then, when you start using it and you value it, I think then it's a really powerful if you can close the loop a little bit, so that you start designing tests that help you increase the quality. But that's kind of the next level. I think at first you can use it as a thermometer to see, how hot or good or whatever is my test suite or not. Yeah. But, of course there are scalability problems. There are many problems. They are probably not impossible to approach. At least not on a unit, smaller level.
Exactly. So other techniques that come to mind except mutation testing? Yeah, for testing.
Yeah, I mean, but this is very personal. Maybe this is too advanced. Maybe if you're talking about applying it today, I think. But you know, if I was like learning, if I was a young researcher or whatever coming into software testing, I would probably go to basics. I mean, applied mathematics on this. I mean, what are the limits? Personally, I have a couple of projects now, papers, studies going on using information theory to understand what does it mean, what are the limits, and I mean even the fact that we can measure diversity. So it's a very normal idea for any tester doing manual testing when they create tests is that if I'm going to create 3 tests, I want them to be different. I don't want them to be super similar, because then I will learn less about how my software behaves.
That's a simple intuition.
Very simple. But how do you formalize this? And I think with some of these tools that we found in information theory and applied, I think we can actually start discussing this more. What does it mean, diversity, on a more fundamental level? And you also get as a benefit some metrics that you can actually use then to optimize and search for better, more diverse test suites, or select. Even we have tried this a little bit. If you are in industry and you have 1,000 test cases in a test suite, you can use these tools to kind of reduce them. So if you only have time to run 50, I mean, you want to select the 50 most different, you can use these tools. So I think that's an idea, but it's probably not at the level where you can download and use it. So
so that's kind of
a more advanced idea.
So what do you think about automated test generation, or create test automatically?
Yeah, but that's such a big field. Personally, I think it's a little bit early for many companies. Unfortunately, I would hope I could say it's not, but I think there has been recent studies showing that, let's say, at least the tools that are currently among the top academically are maybe not so useful. I don't know. There are other papers claiming they are useful, but I think for most companies that I've worked with, it's probably not yet polished enough. I mean, the output is a little bit too muddled maybe, and it's hard to understand and so on. So I doubt most companies or most testers today could download these tools and be super happy with the results. So I think there's still something to be done there.
And, it's also a problem, I guess, that they can be applied to units and small pieces of software.
Yeah,
maybe
like a class in Java.
And some people would like to have it on a bigger level or something.
Yeah, and there's also the problem that in general they are a little bit worse for stuff that takes non-numerical inputs. Or we can handle like integers, floating points, and vectors and matrices and whatnot, and more complex things. But when we get to that level, we probably need to add something to some of these tools to get more structured and meaningful data. I mean, my own group and our own papers, and together with Simon Polding, I've been working now for almost 5 years to take kind of search-based testing into that structured data, more complex data generation. I think we can probably do that today for most structures, but it needs to be tested more and polished more. Right.
So I guess everything is about the future also. But do you think is the field of software testing relevant for the future?
Yeah, I mean, I think it's super relevant. I agree with the criticism that a lot of the research is kind of myopic. It's kind of focused on in the lab. It's focused on improving some metric that some other researchers focus on. And I think it's quite a small change to many of these studies to be more open up and go towards more realistic evaluation. But on the other hand, it's not only the academics' faults. I mean, it's not so easy to go out and find meaningful software systems of a large scale where we can try and evaluate some of these tools. Even if we do it on open source, many companies would say it's still not big enough or it's still not relevant enough. So if companies continue having that stance, they also need to provide us with that access, I think. And some do, but even if they do, it's not always you can publish on it. This has happened to me many times. So,
and some of the companies have research divisions, so they try to do it.
Right, they try to do it on their own, and I would say that there's lot to do on this interface and improving these processes. And I think if you see, I would actually claim that Google is probably taking the lead on opening up data on this. And I think there was an ICSI paper recently this year where with gigabytes and if not terabytes of test data. And of course, if this is made available to the research community at large, that will help a lot. But other companies need to do this, and they have very little to lose. I mean, it often is harder, maybe even in testing, to get them to release the data because they are very afraid of like the PR. You know, they could lose if it says in the morning newspaper tomorrow that Ericsson saw baby B. Some company has 4% of all tests are fail. You know, it sounds really bad. But if that's part of the development, it's not too bad. And, you know, you can always claim that, we fixed that many times ago. You can also say they save all the data, so you can go like 2-3 years back, then it's not so sensitive. And I think this has been solved many times. But the examples from Google kind of shows, I think, what many others need to do and need to do soon. I mean, you need to work with researchers, work together, and also open up and release the data, because that's how you will get much more quickly. It's more efficient for the world and for society if more people can fix these things quickly. I mean, if all the data is closed, we will learn collectively much slower, and this is a problem. This, I think, is the best thing companies can do, is to open up and have a dialogue and work to improve. And often they get many benefits also from that.
I guess this is quite exciting, and like if a lot of companies would do that, I think the research community would.
Yeah, I mean, we're still hoping, and we have the testing ICST big testing conference in Västerås in Sweden next year, and I'm involved with that. I'm the PC chair together with Shin Yu from South Korea, KAIST, and we really hope that we can also have real data sets from companies, large data sets relevant for test research, and make it available. But who knows? This is really up to the companies. And,
that's true. Yeah. So what advice would you have for students getting started in software engineering studies?
Yeah, I think the first thing is to view it like it sounds strange, but holistically. I mean, there are many layers to being a good software engineer. I mean, there are really technical issues, like, you know, hardcore stats needed to understand and evaluate the quality, up to, I mean, pure programming languages, algorithms, and techniques to program them. But there are also many soft and human aspects. And I think if I would give one advice, is that even if you're super interested in the hardcore stuff, you should at least open up and be open to discuss and understand that there are other issues. There are software issues. There are teams, organizational politics. I mean, there's so little research on politics and how that affects software organizations, software engineering.
I think one of the best things, I'm not sure if it is, but I remember when I did my engineer's degree, one of the coolest things was I took a philosophy course.
Oh yeah,
and this is incredible. Just to do you get so much knowledge just by doing something else.
Yeah,
and that helped me quite a lot. And I think just getting courses.
Getting courses, and of course, like you say, I mean, the basic stuff is always going to help you, like philosophy, mathematics. I mean, you know, information theory, like really apply statistics. I mean, super important for all areas of life. And these foundations, you can always be of use if you know these things well. You know. Or how do you design an experiment and evaluate, you know, what you got from that experiment? This is always going to be useful, but when it comes to the more topics in software engineering, I think many university teachers, they focus too much on something, and then sometimes I feel they give students the impression that if I only learn this finite state machine modeling language, software quality issues are solved. No, they are not. You know, for sure they are not solved. I mean, that does not help you at all when the certification agency comes and want to see what kind of quality assurance you have. I mean, it helps you, but it's in no way complete. So I think you should be open to that. This is a huge area. I think if you look at universities, they have 40, 50 divisions or departments that focus on atoms, right? That, from physics up to chemistry, mechanics, and all the way up to construction. How to build the roads and bridges and whatnot. And it's all about how do we align atoms in a certain sense to do what we want. We will have 40, 50 departments in information theory, in information technology, software technology, software engineering, and we have atoms on one bit, but we have information, knowledge, and so on the other side. And I think probably it will be the same, number and size in some sense of research and institutions focusing on that. And you need to see this breadth and why would you close out and say, oh, I'm only going to care about requirements, or I'm only going to care about formal modeling of the architecture, or why do that? I think a broad, basic view, and then of course the basic knowledge is always going to help you, and then be open and continue learning. I think many students, they will have to be more up to date with the research in universities. It will not be okay to go out and then if you know Java today, you go out and in 5 years people use Julia or something else. I mean, what do you do? I mean, you have to. It's not only on the technical level. It's also to the idea of mutation testing, the idea of search-based software engineering. Most software engineers don't know that, even if they graduated a few years ago. This is not going to. People need to know about the powerful and strong techniques, approaches, and ideas. Otherwise, how can they improve? So I think, lifelong learning. It's everyone says that, but it's really concrete. What if you don't do that? What do you then do? I mean, you can't just sit on your ass and expect reality to conform to your skills and ideas.
I think that's a good point. But let's try to go to another topic now. So, which are because now maybe we talked about what students can learn and should maybe learn when they're in their software engineering studies. What are the people that inspired you when you were a student, or even now? It's like during your career.
Wow, that's a difficult one. I must say that the number one that comes to mind is the only psychologist, maybe not the only, but the latest psychologist to get the Nobel Prize. Daniel Kahneman is probably one of the guys I admire the most. Just the strength of different theories and results he has had through the years in psychology, and his approach, and also his wisdom. If you just go to the YouTube or find interviews with him, I mean, he has a breadth of knowledge. And even now, I mean, he in his book a few years back, Thinking Fast and Slow, I think it's named, he made some statements in there about new research areas in psychology that probably turned out to be not the wisest of advice. And to someone at that level, now I think recently he went out and said that no, it was probably wrong of me to promote this type of research. I think it's too early to say. I mean, it's pretty. That's not a very egotistical person. I mean, it requires quite a lot of wisdom, and of course he has kind of the power, and he's an important figure, right? But I think so. It's not really a software engineer, and that has been inspired, but I think he's inspiring, and his work is very inspiring and important, and often you can learn a lot from that. Closer to home, I think I'm more inspired by creative game developers or I don't play a lot of, maybe not I play more kind of mobile games and so on. So I'm not at all an expert in let's say the 3D type of point and shoot or whatever it's called, like third-person shooters.
Yeah.
It's not maybe my thing, but I think there's a lot of, for me, that kind of initial happiness and the power of the computer and kind of interactivity. I think the game industry, in some sense, if you take away the commercial aspects, embodies that in the some of the people that created really good games, from nothing really when we didn't know what type of games there are there.
Yeah,
I think they are inspirational. I think, and I think
and there are a lot of game designers like that.
Yeah, like what's it called? The guy who did Populous and then like the Sim games, and I mean
Sid Meier.
I'm not so very good at games, but I think that type of, so it's not really a person, it's also a kind of an approach to the computer and to computer as a creative tool, maybe, that I think I find that very inspirational.
Oh, that's really interesting.
Yeah.
So do you still write code? What kind of software do you write? What language do you prefer?
I mean, it's like 98% Julia. I just think it's a kind of a brilliant.
Tell me more about Julia.
It's just a brilliant language. So for me, I mean, if I know a lot of programming languages, and my favorite ones are, I mean, Ruby. I was really active in that for long, and I think I wrote a book about it. It's not really a book. I contributed a few chapters to a book, and it's not a really good book. But anyway. I'm on there. So I did a lot of stuff in the Ruby community in a sense, and I liked it. And the thing I liked it is like what people like about Python, that it's kind of dynamically typed, and it's kind of like, it's closer to my idea of the computer as a creative canvas, or something where you can create something, right? Then for me, the statically typed, the kind of the languages that enforces something on me, when it's not always clear yet what I need and so on, then I feel a little bit constrained. And Julia combines many of these ideas and also other ideas from other languages that I love, like from Lisp, many like macros and the kind of that you can self-update your code in a more controlled way. And then it has a super impressive compilation model, and it can get close to C performance while having these really high-level properties is extremely impressive. So I almost switched entirely. I use Julia for most things.
Okay, so you use Julia for software that you use in your research, or
research, and also when I do consultancy work and so on. Because nowadays it's so easy. I mean, if you go 5-10 years back, if you worked with a company, okay, they either wanted C or C++ or Java, and that's it. Or I mean, some wanted C#, but not the ones I worked a lot with. So it was a lot of Java, I guess, and also the research community focused on that. But nowadays, if you consult, I mean, you can package it all in a Docker file, and they don't even need to know what's in there. And typically, what I pack in my Docker files when I create solutions are Julia, R, and maybe Ruby for like some glue code, but less and less, because I can use Julia for that. But Julia will be like, it's a mix of MATLAB, R, Lisp, Ruby with C-like performance. And for me, these 5 languages or so are really powerful ones. And they all have like, okay, I also like Haskell, and I like, and some of the things you can do in Haskell is like magic and really impressive. But it's not the only mode of programming that I like and cherish and have seen value in. And I think for me, Julia has many more of the aspects that I value.
You sold it to me. I need to try it.
Yeah, you can try it. But I still need R in there, because a lot of the new statistics and machine learning and so on is maybe more accessible within an R environment. But luckily, it's just a library in Julia, and you can run any R code from within Julia. So I cannot hide that. But I still need to install R on the Docker files.
Yeah, that's so interesting. But so you're an avid, I would say an avid maybe, you're a Twitter user, right?
I like it, yeah.
Is Twitter useful for your communication with other researchers?
Yeah, for sure. I mean, I never liked Facebook. I don't know. Can you say
Blogging,
this?
Facebook, and
I tried blogging.
Yeah.
I didn't really like Facebook. The whole kind of social, the more like family, private aspect of Facebook is not for me. I don't want to share what I eat. You know, at least now this is a simplistic view, but you know, I'm caricaturing it. But so I kind of stopped that quite early on after trying it. And then I tried a little bit of blogging. I tried maybe doing video stuff for like summarizing papers and so on. But I mean, for me, Twitter is nice, and I can see now it's kind of a big community globally of software engineers, and there's a lot of sharing and quick kind of turnaround of ideas and exchange of things. And I think it has sped up as the double-blind reviewing in software engineering. I think that would have been a slower transition without a lot of the Twitter discussions and sharing of information. It went into that, and so I see that quite clearly. But for me, Twitter, I only use it like for work stuff. I wouldn't, you know, I don't like even Instagram for me. I have an Instagram account, it's mostly for like closest family.
Yeah, I do.
But suddenly you get like invitations from colleagues, and I don't really know how to handle that. Because for me, it's like, no, I don't want to share my picture of my little daughter with a colleague in somewhere. I mean, for me, it's like different worlds.
No, I do the same. I try to keep it separate.
Right,
but you always get some people from work or something that wants to.
Yeah, and even
sometimes it's okay, but sometimes it's not. So
no,
I try to keep it separate.
I think Twitter for me kind of substituted all the blogging and the Facebooking and all that stuff. The non-paper writing stuff goes into Twitter.
Yeah, that's true.
So I like it, and I think it has. I mean, I've met people, and even people that are moving here to Chalmers to software engineering now, that I knew from Twitter. But when I met them, we kind of like, yeah, it's you, right? And that was quite fun. And he's moving in now, one of those guys. So,
It's good for community actually.
I think so.
So before we close, can you recommend 3 books or scientific papers to our listeners that you think it's important for them to read?
I think I wouldn't want to do that about papers. I think that then I would really have to think about it, because I think there are many.
There's so many.
Sorry, but I don't want to pick something out.
But like books in general, it should not only scientific books, maybe just books in general.
Yeah. I don't know about like favorites going way back, but I mean, I tend to, I like science fiction, and not only for like entertainment. I like it for, as a researcher, I think I view it as mostly a creative thing, right? And and how do you train your creativity? For me, it helps to kind of think in new ways, and I think I actually view science fiction more as work, because for me it's kind of like you take a massage of your brain and try to kind of shake up a little bit in the best science fiction. Not everything. I mean, a lot of it can be dull and boring and not full of ideas, but the kind of idea heavy science fiction I think can be used as both setting a goal for stuff we want to do with society and technology and software and AI.
So what would be like a favorite science fiction book? Your favorite science fiction book?
Of course, but I.M. Banks.
I.M. Banks.
The whole series there. Unfortunately, I think he died a few years back, so it's kind of, there are no more books coming, but there are many good books there. I'm sorry, I can't remember, but if I remember correctly, his series are the ones where they are like huge, basically black holes, but they are like really powerful AIs, computers that have kind of a civilization, and they coexist with more human-like creatures. And there's a lot of exciting, I would say, ideas or like shake-up ideas for AI and search and optimization even in those books on a meta level. So
it's interesting. A lot of research, a lot of other scientists do this. Like they read science fiction and they write sometimes. That's something. Yeah.
Yes.
So you're not alone in this.
No, that's true. No.
In a way,
and actually, many of my closest colleagues, we exchange a lot of book advice about this. And I read recently the Raj series. There's it's a trio of books. I think Shelecki or something. I mean, she's an American writer. She's a little bit older. She started writing only a couple of years ago, or she got published a couple of years ago. And the first book won a Hugo Award, I think. And that series, I found that was pretty good. That was my latest one that I can sort of remember, because I read a lot of those that I not always remember. Then Accelerando, Charles Stross. He has a lot of like this idea science fiction that I find quite interesting. I mean, he has these books where there's a society kind of around the sun, because that's kind of the most energy efficient way is to be close to the sun or something. I mean, there are some really nice books from Charles Stross. So there are at least actually 3 authors, if not books.
Oh, I think this is a good selection, I would say.
Yeah.
Cool.
But I would also advise, I mean, software engineering research. If you plan to write a book about in your field, look at psychology, look at biology. I mean, the textbooks they have, I mean, it's another class. I mean, we don't have that type of knowledge yet. I mean, it's my favorite. I have a really thick, the basic book in biology that they used in Gothenburg University. So I bought that when I did my PhD, since it was on biologically inspired algorithms partly. I mean, it's so dense. I mean, one book is like super thick, and each page there's so much knowledge and models, and I think we should all strive to get to that level when we have so much knowledge. If I compare books also that I contributed to, they are mostly like, in some sense, they are almost opinion compared to some of these more, And many of these scientific areas still are in crisis over their use of statistics and so on. But I think that will go for us all. We can all improve on this. But for sure, I'm very impressed with some of these basic science areas and their textbooks. It's impressive.
It is. Yeah. Cool.
Yep.
So, thank you so much.
Thank you.
And this was really fun. Let's do that again sometime.
For sure. My pleasure.
Okay.
Thanks a lot.
Thanks.